Let's go to 110.16. ArcFlash hazard warning 110.16. The code is pretty simple. It just simply says switchboards, switchgear, panel boards, industrial control panels, meter socket enclosures, and motor control centers must be marked to warn qualified persons against an arc flash hazard. We saw a video of an arc flash hazard where we saw that slow motion video where all of a sudden, that's where it was a phase-to-phase fault and there's a hazard. And the code says, well, put a warning on there. Well, that warning example right here, arc flash hazard warning, a lot of times it just comes with the manufacturer. Yep. A little sticker, they stick it right on.
A lot of times.
That, you know, you got to put that sticker on there, so that takes care of that. And what's the purpose of this? Well, the purpose is to kind of alert the user or the installer that there's an arc flash hazard. And here's an example of a phase-to-phase fault on the line side. I'm sure this had to be service equipment. And you can see how this thing just exploded. And the intent is, see, the code is an installation standard, so it's not an NFPA 70E, which is workplace safety and telling you about what kind of protective gear and what kind of labeling and what do you have to do. So it's like, well, but at least we want to warn people that there's an arc flash hazard. And so we put labels on there. And then here's an example of an arc flash hazard. Now there's three people, one person down here, this guy standing here, and this guy standing. And you have two parts of an arc flash, arc blast. One is the arc flash, which is the heat. Then you have the blast, which is actually, I guess, when you expand air so quickly, it just creates an explosion and air pressure, and it just blows people, pushes them away. Watch how far this person right here gets thrown. Remember, this guy down here in the bottom, you'll see, I think he actually dies. That's the information I have. Okay, there is the arc flash. Now we're going to see the blast. Look what happened to him, how far he got thrown out. Now there's a guy, this is one guy that was standing here, got thrown out this way. The other guy is down on the bottom. He's the one that's in the fire area, and that's him right here. He gets thrown from the blast. He's on fire, and if you watch it for a little while longer, you'll see that he's trying to put it all out. And then eventually it just comes back on again. So now he's getting up. Fire seems to be off. Now you'll see it ignite again shortly here. I think it does.
It doesn't. It's actually because his underclothing was flammable, and so that flame front
right there
crawled up underneath his pant leg.
Okay, do you have more information about this case?
Yeah.
Did this guy die?
Did not die.
He did not die. Okay. I don't even know how they happen to have the camera. Anybody know?
Just happened to be a security camera in the
security
yard.
camera.
But somehow they followed him.
The control room, as they caught it.
They just happened to be there, and all of a sudden that event happened inside there. All right, so now we need to have a warning sign, and it's supposed to tell us about this, but it really doesn't really accomplish a whole lot. Now let's go to service disconnect, arc flash warning 110.16b, and it says that in addition to the 110.16a, which is this arc flash hazard warning part, the service equipment label must identify the nominal system voltage, available fault current, clearing time of the service overcurrent device, and the date the label was installed. So at service equipment, if it's rated 1200 amperes or more, we got to put the system voltage 120/208. In this case here, we probably could change it to 208Y/120. Mike, well, let's change it to 208Y/120. I think that would be more appropriate. That would be the IEEE standard. That would indicate three-phase. And then this is available fault current calculation, 18,363. So we'd have to, that's on the line side. And then the clearing time was 0.03 seconds. That's standard. It all depends on whether it's a molded case circuit breaker or whether it's a power circuit breaker or an electronic circuit breaker. So you'll have to get with the manufacturer of that breaker to find out what's the clearing time. and then the date the label is applied. So now what they've done is the code can't require you to have an ArcFlash label in accordance with 70E, but can require you to give me the voltage, the amperage, and give me the clearing time. And if you know the voltage and you know the amperage and you know the clearing time, guess what? You can calculate what's called the incident energy calories. And with the incident energy calories, you'll see later on, then we could actually figure out what kind of PPE. Jennifer.
So this is actually in coordination that if you don't have one, you have something else that can assist you in selecting the correct type of PPE. Because that information that is on that label actually allows you to use the tables that then give you PPE categories. So,
but can't I use that information and do the calculation?
You could, there's still some missing information in there.
Oh, you're right. There is missing information.
But that one gets you to the point where you could dress appropriately for that amount of available fault current, pending that information was all correct. The clearing time and everything else are parameters that are assigned to the specific PPE task tables.
And so that's 70E, what was that table?
130.715A, B, and C.
Okay, 130.7, and it tells you, depending upon the available fault, depending on the type of equipment that you're working on,
The
right?
clearing time.
And the clearing time, it then tells you what kind of PPE equipment that you can use.
Correct.
Okay. Now, the code says, well, you know, you don't have to have that label if you actually have an NFPA 70E PPE label already with the information that you need to have. Because that was, like you're saying, this gives me where I can use a table. Well, now this just tells me, hey, you already got the information calculated out.
Yeah, it kind of aligns with all the other changes they made with all the other standards, so fuel dispensing facilities and all that, where they started naming the particular standard that drives that to be able to assist in coordinating and not having a conflict of application, right? So one standard said one thing, the other said something else. This is kind of aligning the two.
Okay. And then 70E is what this is all driven from, to get us information that we can have. So it's the label, just simply label giving us information. Now this is an example from JRS Consulting, 718-215-5911. Happens to be sitting right over there on the right-hand side, Joel. He got us that label last night. And so let's read this here. All right, this label says that it's 5.6 calorie per centimeter squared at 18 inches. And so that's going to tell me that when I get clothing, I'm going to have clothing that's going to meet that incident energy calculation. And we're going to show some pictures. We'll talk about that. The ArcFlash boundary. So Jennifer, help me out here. The 7 feet 3 inches ArcFlash boundary, is that the distance I have to use the 5.6?
No. So that is the onset of second degree burns, is what that 7 foot 3 inches indicates, is at 7 foot 3 is the onset of second degree burns. Anytime you're walking inside that area, you have to be dressed at a level of incident energy, which is calculated at the 18 inches.
So if I'm within 7.3 feet, let me go over here, then I have to use the 5.6 minimum rated calorie in that area there. Then, this is 13,000 is why this value is so high. Okay, so this is a 13,000 volt system. Okay, we're not getting further there.
Mike, another way of looking at that is that the ArcFlash boundary is where it is at 1.2 calories per square centimeter.
Ah, that's right. Okay, there's not a 70E, and we're not getting into that, but it's 1.2 calories is when you go to a third degree burn? Second degree burn. And that's when it's, okay, you're right, of course. It's a second degree burn, so at 1.2 calorie. And you're saying back over here, the 7 feet 3 inches, that's when you begin the second degree burn. So at that point, we need to have the 5.6 so that you can be where your chest is 18 inches away from the ArcFlash event.
Right. So walking in there, of course, the closer you get, the higher the burn is going to be. So walking into that area at 7 foot 3, that's the onset of second degree burns. That's where we would demarcate our area in order to ensure that people who are unqualified and not dressed appropriately would not be exposed to that level of energy.
But what's the 18 inches part here?
It's a working distance. So it's from your face, neck, head, and torso. So this part of your body is the working distance, meaning that your arms and hands and insulated tools can go inside that area. But what they really want is that the parts of your body that are hard to cure stay outside of that.
So they recognize that even if you have the proper PPE, your hands
Yes.
are going to get more, are
They will be exposed to more energy the
more
closer
energy.
it gets.
And they recognize because that's just,
It's actually the inverse square law working.
Yeah.
So the closer you get, the higher the energy, the further away, the lower.
okay, so we recognize that, okay, as long as you're this part, then you probably should be able to survive. The hands, however,
Right.
might get damaged, and what are you going to do? I mean, you're going to be that close to it, right?
Right.
So, Joe, you going to say anything? We're good?
Yeah, so as an electrician, you need to know that if you are going to work live, you need to understand this label, you need to go through special training. The NEC just says you have to provide a label at time of installation, so when people later come and do the work, they know what to do and how to work safely, should they need to wear to work live. But there's a lot of extra training that you must take to be able to do that.
All right, let's look at this graphic
And that's
here.
way more than what the NEC covers.
So let me review 110.16. 110.16a says, hey, you need to put a label that says, warning, arc flash hazard. Okay, thanks. Does that accomplish anything? No. Okay. And then B says, well, you know, if it's service equipment 1,200 amperes or more, then we really want to have information. We want to know what's the nominal system voltage, what's the available fault, what's the clearing time, what's the date of the location, I mean, the date of that study that was done. And with that information, we can then go to 70E, go to a table, tell us what kind of PPE we should wear to work in there.
Correct.
But if you put a label that is a NFPA 70E label, then I don't have to do the calculation and show the nominal system voltage, the available fault, because we got all the information that we needed on the NFPA 70E label.
Correct.
And that tells me, okay, then Ryan, when you get out there, you see this thing here, it says, hey, listen, if you're going to be between 7 feet 3 inches and that cover is off, then you need to get protective gear that's 5.6 inches, 5.6 calories per centimeter square rated clothing. All right. So here's an example. This is all just simulated stuff. A guy closing a disconnect or whatever it is. Of course, the arc flash would not be that little tiny baby fire, right? It would be a big explosion. And then the person catches on fire and they're running around. So how do you solve that problem? I'll probably get rid of those two slides and just show the arc flash and just say, okay, what do you do? Have the proper safety PPE equipment. Here's an example. A gear is being modified and changed the way it's designed. Years ago, a person would go on the line side of the fusible disconnect to be able to put that equipment back together. And this person happened to have the hard hat, happened to have the gloves, the glasses. Here's another person, they were just plugging in a meter. They happen to have the gloves and the protective shirt. This is what it looks like when there's an arc flash, which we've already shown earlier. And what you have is, look at this jetting of 64,000 expansion times the area because of the heat at maybe, 20, 30,000 degrees. And it's copper, and it's aluminum, and it's steel, and it's plastic, and it's paint, and every other chemical you can vaporize, and then you breathe in, and it goes inside your lungs, and it melts your face, and it melts your fingers, and and you know what? You just hope that you die.
Yep.
Yeah,
Because when
pretty
people survive an arc flash blast like that, and I've been involved in cases, and the person, they have all scar, and the scars, all scars do is they dry up and they shrink. So they have to go in there, they have to cut the scar tissue. And this one guy was a young guy, 26, with a couple kids. It was in Brandon Mall down in Tampa area, Brandon, Florida, whatever it is. He was putting in a square D I-line breaker. Remember the metal? And it somehow it dropped in there. It explodes. He's on fire. He's running down the mall. They take him out. He goes to the hospital. And I'm just bawling, reading the deposition of what's going on. And he had a little kid. He wanted to play baseball with his son, but he couldn't throw the ball because he can't bend his arms. You know what I mean? And you're like, wow, what kind of life? Here I'm a knight in shining armor, and I'm slaying the dragons, and I'm cleaning out the moat, and I'm patching up the castle. I don't know what the prince is doing on the inside. Don't really care inside here. I'm not the... And now I can't clean any moats. I can't patch any castles. I'm not clearing any dragons, and I'm home, and I have no fingers, and I and this is my world. And I think I'm a pretty tough guy. At one time, I thought that if I was quadplegic, paraplegic, that I would just use a straw, or use my eyebrows and move around like that. Now I realize, I think if I'm not really a functioning guy, I think I just want to just jump off the cliff. You know what I mean? I don't think I'm as tough and strong as I think I am. There's some people that are very resilient. I don't know what would happen to me, but it takes a pretty strong person to deal with this and go forward. And you know what? My son's an electrical contractor. I don't want him to have this happen to him. And so the key here is this. The only reason we put protective equipment on is to verify that it's off, not to work on it. Because we're going to turn it off, then we're going to lock it out, we're going to tag it out, then we're going to go there, and we're going to then take a voltmeter, and then we're going to go through the absence of voltage test, check your voltmeter, make sure that you measured on something that is voltage. Okay, the meter worked. Okay, verify that. Okay, voltage is not there. Okay, go back to the apps, go back to the voltage source, verify. Okay, the voltage is not there. But even that doesn't mean it's safe, because you could have miswiring inside the building where your neutral conductor could be connected to another circuit inside the building, but yet you open up the disconnect or the transformer, and then you don't realize that you simply take a neutral conductor off, and sometimes an equipment grounding conductor, and you can get killed. So the fact that the power is off doesn't mean that there's not current traveling inside that thing. So we're not going to get into all the safety applications. You do not work on anything hot. Period. You turn it off. It's just that simple. If you're an electrician and they require you to work on it hot, just say, send me to another job. I'm not going to work on it hot. It's not worth your life, your family, your kids. Nobody wants you to have that happen to you. So this is just an example of what it might look like. This is not a real person, because I'm not going to show. We go on the internet, you can see people that have been smoked because of a lot of stupid things, like stealing aluminum wire on a utility power line that's energized. I'm not quite sure what's going on there. Yes, ma'am.
I want to say just it's a really easy thing for us to forget, because what we do is dangerous, that it can happen to any one of us. Eric and I know people that have had this happen to their family members, and it does hit close to home. It can happen to you if you're being cavalier and you're doing it because you're an electrician and you're awesome and you can do live work. You might not make it home if you do that. So keep in mind that, you know, the preferred method is de-energized, and if you can accomplish that, then we're already making headway. But other than that, other requirements are in place, and that's not just by this standard, it's also by OSHA.
Okay, Brian, yeah?
Yeah, just not to make this any more of a downer than it already is, because it's not really a pleasant subject, but a very good friend of mine who worked for me for years recently was out doing a service call in the evening, doing adding a piece of wire that burned up, replacing a piece of wire in a live panel, and blew it up because it accidentally contacted an energized part. It vaporized, it caused an arc flash, pretty severe burns to his face, chest, and arms. And if he had had his PPE on, he would have been fine, like no injuries at all, because it was not a big deal. He's done this every day his entire life. I mean, he's been a service electrician for 20 plus years. And he's a good service electrician, very good service electrician, and it happened to him. And I think, and then one of my oldest foster boys, his working partner, the journeyman that he worked with, somebody turned on a breaker that was turned off in a locked room behind a locked door with a tag on it while he was working on it, and it blew up, and it put him in the hospital for several months. So, you know, I think we all have a tendency to think it's not going to happen to us, like Jennifer says. You know, you made a comment about that wasn't a very big arc flash, and you would have thought it would have been a bigger arc flash. And I actually know a guy that was working in a box plant that we did a lot of work in, that had some petroleum products on his clothing. Ooh. And he closed a disconnect and an inverter motor VFD, faulted somehow, and just vented a little, not a lot, just a shower of sparks or a little small flash, and caught his clothing on fire. And it wasn't the arc flash that did the damage, it was his clothing burning that put him in the hospital for 6 months and multiple surgeries. So, you know, I really think that we don't generally as an industry, because we all typically all start doing construction first, like installation, we don't deal with things that can hurt you to start with, and we get callous to the environment that we're working in. We get callous to that you can't see the electricity, you can't hear the electricity, shouldn't be able to anyway, can't smell the electricity. And so it just becomes then a mechanical thing, and we forget that that mechanical thing represents a very big danger to us, to the people that are going to use it after we leave, to the other people that we're working with, and that our actions can directly affect other people for the rest of their lives, like you said. So it's a very sobering topic that I don't know that we need to dwell any more on it as far as this topic or this is concerned, but I think it needs to be more on the forefront of all of our minds as we're working in this industry.
I'm a 9-time national barefoot water ski champion. I'm world class. Everything that I do in barefooting, you know what happens? I make mistakes and I fall. I'm not doing barefoot anymore. I'm into mountain biking. But let's just say when I was the peak at my barefooting, which was 61 years old, was when I peaked, I fall. It happens. Doesn't happen that often, but you're going 47 miles an hour, barefooting, 1 foot, and something happens, you just make that slight little mistake, it really hurts. But that's just barefoot water skiing. In electrical, you will always make a mistake. I don't care how good you are in any sport. You will make a mistake. The only question is the timing of that mistake and the consequence that that's going to take place. And to think that somehow you can work it hot, that somehow you're going to be okay. He was just hooking up a wire that he's hooked up 1,000 times.
Service call.
Service call. We're talking a
quick little
nothing
deal.
thing. So, all right, like you said, I think we've done enough on this. Here's just an example of person working over here. And you can see what happened on that wall there. You can see the hat, and you can see the, what do you call it? Balaclava, whatever.
Balaclava.
Balaclava. I have pictures of his face and his hands, so I just figured, I want you to know there's a real person here without it, we don't have to show his face there. Imagine when that thing took off. The problem is when you work on service equipment's a definition, and service equipment is what you cut off the power from the electric utility. Well, on the line side of that service equipment, there is no clearing time. There is no protection. There is no limit to the energy. We can't even calculate out what that energy would be. We don't know what it's going to be. So that's even the worst case scenario is on the supply side of the service. Here's just another example looking at that. That's a big deal. So here's the clothing, Ryan. You go and you look at the label. It says 5.6. Now, I don't know clothing, so 5.6 would require, what, a 12 or something like that?
No, 5.6.
An 8?
You could buy clothing that's rated higher than that, but an 8 cal clothing.
Okay, I didn't know what the numbers were. That's what I'm saying. Is it like 4 and 8 or something like that?
The standards are 4, 8, 25, and 40, but there's all stuff in between that you could buy as a layering system that could be 12 or 16 or 22, depending on what you want to buy.
Remember we talked about torquing? It's an important thing to me, and I think we do a terrible job as an industry on that. Yeah, well, right here is another example. Understanding this hazard and having the proper PPE. And you said, Ryan, well, the contractor has to teach us, and they have to give us a tool. Well, the contractor has to teach and has to give you the tool.
Absolutely.
Here's just an example of a spacesuit. This is the FAA. I did a seminar for them and covering a little bit that there, and they show us what they have to work with in some cases.